In this last video for section 7.3, we'll actually do a review problem for chapter 6. So in this example, we're asked to find a general solution to the differential equation d squared minus 1 times d minus 2 acting on y is equal to e to the power x plus x. So general solution, when we write that down, the general solution will be of the form y of x is yh of x plus yp of x. So the homogeneous solution, this is the homogeneous solution and the particular solution. The homogeneous solution we find by looking at the auxiliary equation. So when we look at the operator notation, this directly translates to the auxiliary equation. So when you look at d squared minus 1 in a product, that means that you set r squared minus 1 equal to 0, and it means that r equals plus or minus 1. And so that takes care of this first factor. And then the second factor is r minus 2 equals 0, so r equals 2. And that leads to the homogeneous solution having the ingredients e to the power 1x, e to the power negative 1x, and finally e to the power 2x. So our homogeneous solution looks as follows. That's c1 e to the power x plus c2 e to the power negative x, and then plus c3 e to the power 2x. Now, in order to find the particular solution, we could use a method of undetermined coefficients, and I would definitely recommend you trying to solve the problem with undetermined coefficients. But what I will do is I will solve this problem using annihilators. So because the particular solution will actually be two parts, a particular solution for e to the power x and a particular solution for x. But let's take a look at annihilators. So e to the power x, and you can look this up in your table for annihilators. The annihilator for that is d minus 1, and the annihilator for x is d squared. So the total annihilator is going to be d squared times d minus 1. So let's write out our original differential equation. So that is d squared minus 1. I'm going to factor that as d minus 1 times d plus 1 and times d minus 2 of y equals e to the power x plus x. And I'm going to apply my annihilator on both sides. So d squared times d minus 1, and that will be 0 because of the way we chose the annihilator. And so if we apply the d squared times d minus 1 on the other side, what we get is we just multiply this through, and then we get d squared, and then d minus 1 times d minus 1 gives you d minus 1 squared times d plus 1 times d minus 2 y equals 0. So at this point, we can take a look at the auxiliary equation again, because we've turned this equation into a homogeneous equation. So let's take a look at the parts of the differential equation. So d squared, that translates to r squared equals 0. So that's r equals 0. And the multiplicity is 2. So the functions that you get are e to the power 0x, and then x e to the power 0x, or just e to the power 0x, that's just 1, and then x times e to the power 0x, that's just x. So we get 1 and x for that. And then for d minus 1 squared, we get r minus 1 squared equals 0. And so that is r equals 1. And that's also of multiplicity 1. And so the corresponding solutions for that are e to the power x, and then x e to the power x. And then we go to d plus 1, that's r plus 1 equals 0. So that's r equals negative 1 of multiplicity 1. So that corresponds with just one function, e to the power negative x. And then finally, we have our d minus 2. That corresponds to r minus 2 equals 0. So just r equals 2. And the corresponding solution there is e to the power 2x. So now to figure out what the particular solution looks like, we need to get rid of the functions that are already part of the homogeneous solution. So let's underline the ones that we see in the homogeneous one. So this one is part of YH, this is part of YH, and this is part of YH. And so the three functions that are not part of the homogeneous equation are 1x and xe to the power x. So that means that our particular solution of x is of the form c4 times 1 plus c5 times x plus c6 times x e to the power x. So that's our second part of our general form. Now, we cannot determine what C1, C2, and C3 are, because that depends on initial conditions. However, if we need to find a general solution, we can find C4, C5, C6. And in this case, we'll have to find those C4, C5, and C6. If it said find a form of the general solution, we could just add this up and be done. So our in-between answer, if we just want the form of the general solution, it would look like this. Y of x equals c1 e to the power x plus c2 e to the power negative x plus c3 e to the power 2x, and then plus c4 plus c5x plus c6x e to the power x. And this is the general form. It's the form of y of x. But we need to find the general solution. And so that involves taking this part, plugging it into the differential equation, and figuring out what the constants are. And in the interest of time, to not make this video too long, I will show the work here and plug this in, and then just show you the final values of C4, C5, C6. So this is a good moment to pause the video and see if you can plug this in and figure out what C4, C5, and C6 are. Okay, so what I did here is I took the particular solution, C4 plus C5 times x plus C6 times x e to the power x, and I want to take that and plug it into the original differential equation, which is d squared minus 1 times d minus 2. And so we can FOIL this out, and we see that our differential equation is of third order, d squared minus 2d squared minus d plus 2. So that means we need up to the third derivative of the particular solution. So the particular solution is given here. Here's the derivative, the second derivative, and the third derivative. So if we plug that into the differential equation here, d cubed, that's the third derivative of our particular solution, minus 2 times d squared, that's the second derivative, etc. And we set that equal to e to the power x plus x. And then it's bookkeeping here. So if we combine all the terms with e to the power x, we end up with this expression here. And then we combine all the other terms, we end up with this right here. It turns out that all the terms with x, e to the power x, they cancel out. We get a 0, and then the constant c6, all the terms with c6 end up being negative 2c6 times e to the power x. And then the second part is this with c4 and c5. If we then subtract e to the power x on both sides and we subtract x on both sides, we get this expression here, negative 2c6 minus 1 times e to the power x minus c5 plus 2c4 plus 2c5 minus 1 times x equals 0. And because this has to hold for all x, we know that this has to equal 0, this has to equal 0, this has to equal 0. So this is straightforward to solve. We see that c6 equals negative 1/2, and this is straightforward to solve. We see that c5 equals 1/2. But once we have c5, we can also easily find c4. We plug in 1/2 for c5, and then we solve for C4, that's 1/4. So the general solution to our differential equation consists of the homogeneous part of the solution that's given right here, and then the particular solution we use C4, C5, and C6, and this is the particular solution. And so this is the entire answer for the general solution.